Imagine this. It's the 1960s, and the most powerful computer of the time isn't something you carry in your pocket or place on your desk. It's a giant, a behemoth of wires, vacuum tubes, and whirring fans, so large it fills an entire room, wall to wall. These machines required massive amounts of electricity just to operate. They needed constant water cooling to keep from overheating, and only a handful of elite institutions, government agencies, banks, and universities had the privilege of using them. Access was exclusive, the technology was expensive, and despite all the buzz, the computing power was limited by today's standards. Now fast forward over half a century and take a look around. We've made monumental progress, but in some ways, we've repeated the same mistake. Only now, instead of room-sized mainframes, we've built hyperscale AI data centers. Facilities the size of warehouses, packed with servers humming 24/7, consuming unimaginable amounts of power to train algorithms and feed artificial intelligence. These centers are modern marvels, but they come at a cost. They're energy hungry, water intensive, and if we're not careful, dangerously unsustainable. If we don't rethink how we scale this technology, if we don't change our mindset, these modern giants may end up failing us just like their predecessors once did. In the early days of computing, mainframes were hailed as the pinnacle of innovation, the future of information processing. These machines were enormous, centralized, and incredibly expensive. They lived in locked rooms, managed by specialists, and served only a few users at a time. But over time, something became clear. This model wasn't scalable. It was fragile, inflexible, and left too much power in the hands of too few. Then came the shift. First, we saw the rise of mini-computers, smaller, more affordable systems that began to break down barriers. That gave way to personal computers, machines small enough to sit on a desk, yet powerful enough to put creativity and computation in the hands of millions. As networks grew, servers emerged within companies, and eventually we reached the era of the cloud, decentralized, distributed, and accessible from anywhere on Earth. The pattern is undeniable. When we decentralize computing, we unleash innovation. Every time we've made technology smaller, cheaper, and more accessible, entire industries have been born, and the world has changed with them. You won't believe how phones changed everything. Let's rewind to the beginning of telecom. There was a time when making a simple phone call meant plugging into a vast centralized system, completely controlled by a phone company. You couldn't just dial someone directly. You needed an operator, a real human being, who manually connected your call through a maze of wires and giant electromechanical switches. Behind every call was a massive infrastructure, copper lines stretching across continents, enormous switching stations, and a small army of technicians just to keep things running. It was powerful, but slow, expensive, and completely centralized. Then came the shift. First, the hardware started to shrink. Rotary phones turned into push-button devices. Then came cordless phones, breaking the tether between us and the wall. But the real breakthrough? Cell towers. Suddenly, communication wasn't tied to a fixed location. We decentralized. Signals could bounce from tower to tower, freeing us to move and still stay connected. And with each generation, 2G, 3G, 4G, now 5G, the power in your pocket grew exponentially. Today, the smartphone you carry isn't just a phone, it's a global communications hub. It handles calls, texts, emails, video conferencing, satellite navigation, social media, media production, things entire departments used to be responsible for. The kind of capability that once required an entire telecom company now fits in the palm of your hand. Let that sink in. What once took thousands of employees, miles of cable, and acres of infrastructure is now available to billions of people instantly. That's the power of decentralization. And more than that, it's the power of people. Because every time we've taken control away from massive institutions and put it into the hands of individuals, innovation exploded. Telecom didn't just change. Phones changed everything. Here's the uncomfortable truth about where we are today. Artificial intelligence, the most advanced technology of our time, is still operating under the same centralized mindset we used in the mainframe era. The biggest AI models, those powering your chatbots, search engines, and recommendation systems, are all running inside hyperscale data centers. But at what cost? These facilities are enormous. Some of them consume more electricity than an entire town just to function. They pull in millions of gallons of water every day just to keep their machines cool. That's not just unsustainable, it's alarming, and the risks go beyond the environment. Hyperscale means centralization. If one of these mega centers goes down, entire regions of the internet could go dark. One glitch, one outage, one cyber attack can have global consequences. And perhaps most troubling of all, control is consolidating. A handful of tech giants now dictate how AI runs, who can use it, and where it lives. We've built a digital world that's too centralized, too fragile, and too opaque. Hyperscale AI isn't just inefficient, it's unstable, and it's a problem we can't afford to ignore. But what if there's another way? A smarter, more resilient path forward. It's called the edge. Instead of relying on a handful of hyperscale data centers that are huge, expensive, and vulnerable, we build something else. Imagine thousands of smaller, smarter data centers distributed across cities, rural areas, coastlines, ships, aircraft, and even satellites in orbit. These edge nodes bring AI closer to where it's needed, dramatically reducing latency and speeding up response times. No more sending your data halfway across the planet just to get an answer. They're also greener. Powered by solar, wind, and next-gen battery systems, edge centers can operate off-grid, sustainably, and independently. And here's the real game changer, resilience. If one node fails, the rest keep going. There's no single point of failure because the intelligence is distributed. But maybe the most exciting part, EdgeAi breaks the monopoly, especially HyperEdgeX edge data centers that are both air and immersion cooled ready. It puts computing power back into the hands of people, governments, schools, hospitals, small businesses, and even individuals. AI no longer has to live in the hands of big tech. With EdgeAi, it can belong to all of us. History has shown us this pattern before. Once mainframes ruled the computing world, massive, expensive, controlled by a few, but they didn't last. They were replaced by something smaller, more personal, and infinitely more powerful, the personal computer. Centralized telecom systems met the same fate. What once required miles of cable, switchboards, and monopolistic control eventually gave way to the mobile revolution. Networks of towers, chips, and phones that put power in every pocket. Every centralized giant eventually falls. And hyperscale AI data centers, they will too. The question isn't if, it's when. The death is evident before it has even begun. And more importantly, will we lead that shift? Will we embrace the promise of edge AI, distributed intelligence, and open access? Or will we sit back and wait until the cracks in the system become catastrophic? Because make no mistake, if we continue down this path of centralized hyperscale infrastructure, we are choosing a future of concentrated control, resource depletion, and digital inequality. We're talking about AI, the most powerful technology of our time, and we're putting it in the hands of just a few companies behind closed doors running in energy-guzzling megastructures. That's not just a technical flaw, that's a moral risk. It's not sustainable for the planet, and it's not fair or safe for people. The future of intelligence must be shared, and if we're bold enough, we can build it that way, together. We the people can dictate the type of AI we want. And one day, that AI will be at the edge where you live, work, and play, as the people will one day own and control their personal data via sovereign AI systems and platforms. To everyone listening, you're not just a user of AI, you're a stakeholder in the future. What we build next depends on the questions we ask today. So start asking, where is my AI running? How much power is it pulling from the grid? Is it clean? Is it local? Or is it just another oversized mainframe waiting to collapse under its own weight? The future of AI doesn't belong in megastructures guarded by a handful of corporations. It belongs at the edge, closer to people, powered by renewables, and designed for resilience. And the good news? That future isn't far off. Right now, teams at American Lithium Energy, HyperScaleX, and GridEdgeAi are changing the rules of the game. They're building battery-first, edge-native AI infrastructure that doesn't wait for permission and doesn't rely on the grid. It's mobile, it's modular, and it's ready to deploy today. History has shown us again and again, decentralization wins. The only question is, will we lead the shift or wait until it's too late? If you liked this video, please hit the like button and please don't forget to subscribe. Let me know your thoughts about this video and whether hyperscale AI data centers are sustainable or not in the comments below. This is the Watt Hour. I'm William Hadala. Thank you for listening. Let's keep electrifying Earth and beyond. Be safe and make it great.